Have you ever seen a sign like this, or this? Well, in this video, we are going to be talking about all these signs and how they can be used in an equation. This is BrainBoost, and this is Modular Arithmetics. So firstly, what is modular arithmetics? Modular arithmetics is a system of arithmetics for integers when numbers wrap around after reaching a certain value, called the modulus. It's like a clock. After 12, the clock resets to 1. We can use the symbol mod or mod x to denote the modulus operation, which finds the remainder when one number is divided by another. For example, 13 mod 5 equals to 3. This means that when 13 is divided by 5, the remainder is 3. These are the methods of solving modular arithmetics, which are basically three methods, which are remainder method, clock method, and clock method there are two, clock method 1 and clock method 2. Note that other methods exist. Remainder method is simply when you add, subtract, multiply, or divide a and b, which are numbers, and divide the answer by the modulus, which is a specific number like modulus 8, 9, or 10. As the name implies, your remainder will serve as your answer. For example, if we have 3 remainder 0, our answer will be 0. There are 4 laws guiding this method, which will be covered in the remaining aspects of this video. Clock method 1 is simply when you draw a clock, depending on the modulus, e.g. 12, 6, 7, 5, etc., and replace the mode on the top of the clock with 0. Then you add, subtract, multiply, or divide all the numbers and divide by the mode by rolling around the clock. And you have to take into account that you roll around the clock in a clockwise direction when the integer is positive, also known as our number if it's positive, or counter or anti-clockwise if the integer is negative. Clock method 2 is simply when you get the values of a and b before using the clock, depending on the modulus, to add, minus, multiply, divide, and get your remainder. It is in between remainder and clock method. You have to note that when your answer is negative, you add your modulus until your integer becomes positive. That is for remainder method. Remainder method. There are basically 4 methods of solving modular arithmetic using these methods. As we said, the laws: addition, subtraction, multiplication, and division law, which you can all see on the screen. Let's take some examples. Let's say a equals to 20, b equals to 5, and our mode is equals to 2. When we see r, we take it as remainder. Addition. Using the law, 20 plus 5, which is our a plus b, equals to 25. And then 25 divided by 2 equals to 12, remainder 1. So our answer equals to 1. Subtraction. 20 minus 5 equals to 15. So when we divide 15 by 2, it's 7, remainder 1. So our answer is 1. Multiplication. 20 times 5, we know that's 100. 100 divided by 2 is equals to 50, remainder 0. So our answer is 0. Division. 20 divided by 5 is 4. 4 divided by 2 is 2, remainder 0. So our answer is 0. So let's look at some negative integers. As we said, when your answer is negative, you keep on adding that mode until your answer becomes positive. So when we have minus 7 plus 4 mod 6, it's equals to minus 3, because minus 7 plus 4 equals to minus 3. So minus 3 plus our mode, which is 6, equals to 3. And when we divide 3 by 6, we have 0, remainder 3. So our answer will be 3. 5 minus 10, mode 5. We're going to say it's going to be minus 5, because 5 minus 10 is minus 5. Minus 5 plus 5, which is our mode, will be equals to 0. Clock method. We know this as a normal clock, and then this, we look at it as a modular arithmetic clock. As we said, we replace the mode on the top with 0. So all these are mode 12. So now we look at mode 7, and then the clock is going to look like this, because we replace the 7 on the top with 0. And then this is going to be, yes, a mode 9 clock. So when we have a modulus 21 clock, pause the video and try and draw out how modulus 21 will look. It's going to look like this because we replace the 21 on the top of the clock with 0. So we have to take into account all of the following. So let's look at some examples. This is going to be a modulus 12 clock. So the examples are 10, 10 plus 5, 20 minus 3, 24, and 4 times 4. This will be our answers because, as we said, we know the answers of a number by counting around the clock. So 10, 1, 2, 3, we come all the way to 10, so it's not going to go round, so our answer will be 10. 10 plus 5 is 15, so we're going to have 3. 1, 2, 3. Let me try and make things easier by doing like this. So we're going to get this sketch, minding my ugly writing. So when we have 10 plus 5, as we said, is 15, and we can see 15 is with 3, so it's 3. And then you can also say this as 15 is congruent to 3, which we're going to be covering in other aspects of this video. So 20 minus 3, which is 17, as you can see, 5, so we have 5. 24, which is a new day, so you're going to have 24. So when they say 24 o'clock, it's a new day. So 4 times 4, 16 o'clock, you're going to have 4 o'clock. So let me give you some practice to try on the modulus 7. So pause the video and give it a try. This will be your answers, which are 6, 5, and 5, because 13, you're going to roll around the clock once, which will give you 7, 8, 9, 10, 11, 12, 13. So that's 6. Then 12, you roll around the clock once, 7, 8, 9, 10, 11, 12. Then 5, you're not going to roll around, you're just going to stop at 5. So when we look at some negative ones, let's take some examples. Minus 5, minus 13 minus 15, and minus 5 plus 2. We're going to have 5. As we said, we spin around the clock in a clockwise direction if the integer is positive. That's all what we've been doing here. And then if the integer is negative, in clock method, you spin anti-clockwise, which is opposite of the clock direction. So we're going to have minus 5. 1, 2, 3, 4, 5. Minus 13 minus 15 is going to be minus 2. So we have 1, 2. And then minus 5 plus 2, we're going to have minus 3, which is 1, 2, 3. And then we start counting from 1 and we take 1 as 1. As you can see in all these parts, when we had 10, we didn't start counting as 1, 2, 3. We started counting as 1, 2, 3. So you start from 1 and take 1 as 1. That's what it means. So you can write this down and practice more. Then we have our top 10 test, also known as T, which will be a top 10 question to see whether you understand and paid attention to what you've been taught throughout the video. It will be a test of ability. So let's head over to the first sign in modular arithmetics. Addition of modular arithmetics. Example 1. 13 modular addition, 8 mod 7. We're going to be using 3 methods, which are remainder method, clock method 1, and clock method 2. For our remainder method, we're going to have 13 plus 8, which is equal to 21. And we're going to divide our answer, or our addition, by our mode, which is 7, which we're going to have 3, remainder 0. And our remainder will serve as our answer, so our answer is 0. For clock method 1, we'll draw a clock depending on our mode. Then we add 13 and 8, which is 21, as we got here. And then when we want to find 21, you go around the clock 3 times: 7, 14, 21. So we land and stop at 0, so our answer is 0. For clock method 2, we find the value of our 2 values, which are 13 and 8. And 13, 7, 8, 9, 10, 11, 12, 13, 6, and then the value of 8 is 7, 8, 1. Then we have 6 plus 1, which is equal to 7. As you said, it's in between clock method and remainder method. So we're going to now divide it by our mode, which is 1 remainder 0, which is equal to 0. All the answers are the same. Example 2. 9 modular addition 11 mod 10. So for remainder method, we're going to have 9 plus 11, which is 20, and then we divide by our mode, which is 10, which we're going to have 2 remainder 0. So our answer is 0. For clock method 1, we have 9 plus 11, which is 20, and then 20 is going to go around the clock twice. So, and we stop at 0. 10, 10, which is 20, so our answer is 0. For clock method 2, we are going to have value of 9, value of 11. Value of 9 is 9 because it's just going to count and stop at 9. And then 11, we have 10, 11, 1. 9 plus 1, which is equal to 10. Then we divide by our mode, 1 remainder 0. So our answer is 0. Example 3. 10 modular addition 7 mod 5. We're going to have 10 plus 7, which is equal to 17, divided by our mode, which is equal to 3 remainder 2. So our answer is 2. Then for clock method 1, we're going to have our answer addition 10 plus 7 is 17. We're going to have going around the clock, it's going to be 5, 10, 15, remainder 2. So it's going to stop on 2. And then for clock method 2, we find the value of 10 and the value of 7, which is equal to 10 is 5, 10, which is 0, and then 7, 5, 6, 7, 2. And then we're going to have 0 plus 2. Since it's in between clock and remainder method, it's going to be 2 divided by our mode, 5. It can go 0 times remainder 2. So our answer is 2. And when you want to say the answer of this, you can say 10 modular addition 7 mode 5 is equal to 2. If you've watched this video to this extent, please consider liking the video and subscribing to the channel. It's free. I just told you to subscribe, but you didn't subscribe. Please, hit that subscribe button. Thanks. Subtraction of modular arithmetics. 10 modular subtraction 15 mode 6. We subtract 10 minus 15, which will give us minus 5. And we keep on adding our mode until the integer becomes positive, as we said earlier, which will give us 1 or plus 1. So our answer is 1. Clock method 1. We have 10 minus 15, as we said, minus 5. And we count in an anti-clockwise direction if the integer is negative. So we have 1, 2, 3, 4, 5. The answer is 1. Clock method 2, we're going to find the value of 10 and the value of 15. The value of 10 is 4, the value of 15 is 3. And because of this is modular subtraction, we're going to have 4 minus 3, which is equals to 1. Example 2. 8 modular subtraction 5 mod 4. Subtract 8 minus 5, which is equals to 3. And there's no need of dividing if your answer is not up to your mode. Or if we're going to divide, it's going to be 3 divided by 4, which is 0 remainder 3. So our answer is still 3. And then, clock method 1, we have 8 minus 5, which is equals to 3. 1, 2, 3. Our answer is 3. Clock method 2, 8 and 5. Value of 8 is 0, value of 5 is 1. 0 minus 1, which is equals to minus 1. And then you add the mode until the integer becomes positive. And in this case, our mode is 4. So we have plus 4, which equals to 3. Example 3. 18 modular subtraction 29 mode 2. So we're going to have 18 minus 29, which is equals to minus 11. As I said, Keep on adding the modulus to the number till you get a positive integer. So we're going to have minus 11 plus 2, which is equals to minus 9, plus 2 equals to minus 7, plus 2 is going to be equals to minus 5, plus another 2, minus 3, plus 2, we have minus 1, plus 2, we have 1. So our answer is equals to 1. And for clock method 1, our clock is going to be like this, 0, 1. So we're going to have 18 minus 29, which is equals to minus 11. Then we're going to start by taking 1 as 1, as we said earlier. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The answer is 1. Clock method 2, 0, 1, because it's mode 2. So the value of 18 and the value of 29. The value of 18 is 0 if you take 1 as 1 and you start counting. And then the value of 29 is 1. So 0 minus 1 equals to minus 1. You add your mode, minus 1 plus 2 equals to 1. So our answer is 1. Or you can say you divide 1 by 2, which is our mode, which will give us 0 remainder 1. And our answer is 1. Multiplication of modular arithmetics. Example 1. For modular multiplication 9 hold 5. For this, we are going to multiply 4 times 9, which will give us 36. Then we'll divide by our modulus, which is 5. And then we're going to have 7 remainder 1. So our answer is 1. For clock method 1, 4 times 9, as we said, is 36. Then it's going to roll around the clock 7 times and stop here. Then 30, that will be 35. Then here I'll make it 36. So our answer is 1. Clock method 2, the value of 4 and the value of 9. The value of 4 will be 4. The value of 9 will be 4. Then we have 4 times 4, which is 16, and 16 divided by a mode, it will give us 1. Example 2. In this case, we are going to multiply 7 by 6, which is going to give us 42. And then we divide by a mode, which is 4. Our remainder will be 2. So our answer is 2, because 4 can go in 40 10 times. And then for clock method 1, 7 times 6, 42. It's going to roll around the clock 10 times, which is 40. Then 41, 42. So our answer will be 2. For clock method 2, the value of 7 and the value of 6. The value of 7 is 3. The value of 6 is 2. Then we have 3 times 2, which is equals to 6, divided by our mode, which is 4. We're going to have 1 remainder 2. So our answer will be 2. Example 3. 10 modular multiplication 8 over 3. We're going to multiply 10 times 8, which will give us 80, and then 80 divided by our mode to go 26 times remainder 2. Because if you multiply this by 3 to give you 78, then the remainder 2 will give you 80. Then in this case our answer is 2. Then for this 80, 10 times 8 is going to go around 26 times, and then it will be here 1, 2. We have 2. Then clock method 2, value of 10, value of 8. Value of 10 will be 1, value of 8 will be 2. Then if you use your clock, our answer will be 2. Then you can say 2 divided by 3 is 0 remainder 2. So our answer is 2. Division of modular arithmetics. 14 modular division 2 mode 3. 14 divided by 2 is equal to 7, and 7 divided by our mode 3 is equal to, we can also say this as 7/3, and it will be equal to 2 remainder 1. We take our remainder as our answer, therefore our answer is equal to 1. Clock method 1, 14 divided by 2, we said it's 7. 7 will go around the clock twice and end on 1. So answer will be 1. Clock method 2, 14 is equal to 2 using the clock. 2 is equal to 2 using the clock. 2 divided by 2 is 1/1, which is the same thing as 1. And 1 divided by our mode 3, 0 remainder 1. We take our remainder, so our answer is 1. Example 2. 12 modular division 2 mode 4. 12 divided by 2 is equal to 6. 6 divided by our mode 4 is equal to 1 remainder 2. Therefore, our answer is 2. Clock method 1, as we said, 12 divided by 2 is 6. Using this, it will go round. This will be 4, 5, 6. So it stops on 2. Therefore, our answer will be 2. Method 2, 12 is equal to 0. 2 is equal to 2. 0 divided by 2 equals to 0 remainder 2. So therefore, our answer is 2. Example 3. 15 modular division 7 mode 4. 15 divided by 7 mode 4 is equal to 2 remainder 1. And in this case, we take our remainder, which is 1 mode 4, which is the same thing as 1. So you can say this as 15 modular division 7 mode 4 is equal to 1. Clock method 1, 15 divided by 7 is 2 remainder 1. We take our remainder, we just have 1, so our answer is 1. And then for clock method 2, 15 is equal to 3. 7 is equal to 2. 3 divided by 3 equal to 1/1. The answer is 1. In any case where when you use the division, it mostly happens in division. When you divide and then you're having a remainder at first, when you've not divided by the mode, you take the remainder and divide by the mode. And we have to note that division of modular arithmetic is the most complex one of them all. It comes in various forms, which requires various methods. This makes it to not be frequently asked as other modular arithmetic signs. For this question, 18 plus 27 minus 12 in brackets times 3 divided by 2 mod 5. Using remainder method, we are going to open the bracket first, as we know. Odd mass brackets. So we open our bracket, which will be 18 plus 27 minus 12. Firstly, 18 plus 27 is equals to 45. 45 minus the 12 will give us 33. And then 33 times these are 3 here will give us 99. And we divide 99 by our 2, which will give us 49 remainder 1. So since we're using remainder method, 1 will serve as the answer from all this. Then if we divide by our mode 5, we're still going to have 0 remainder 1. The answer is still 1. Using this method, we're just going to do all this over again and we'll get to this 1 point. So you just count 1. So you just still have 1. And then using clock method 2, you have to find the value of all the numbers, which is 18, 27, 12, 3, and then 2. So the value of 18 is 3, the value of 27 is 2, the value of 12 is 2, the value, using the clock that is, the value of 3 is 3, and the value of 2 is 2. So we have 3, 2, 2, 3, 2. Then we substitute it in this equation. So it's going to be 3 into bracket 2 minus 2 close times 3 divided by 2. We open our bracket, 5 minus 2, because 3 plus 2 is 5, minus this 2, it will give us 3, as we did before. 3 times 3 equals to 9, divided by this 2, which is equals to 4 remainder 1, because 2 in 9 can go 4 times remainder 1. So we divide 1 by our mode 5, which will give us 0 remainder 1. Therefore, our answer will be 1. If you don't understand, reverse and go through the video again. The next, congruence in modular arithmetics. Two numbers a and b are congruent modulo n if they leave the same remainder when divided by n. A is said to be congruent to b mod n. Example, 23 is congruent to 3 mod 5. This means 23 mod 5 is equal to 3 and 3 mod 5 is equal to 3. Because if you divide 23 by 5, which is the mode, it can go 4 times, which is 20, remainder 3. And 3 divided by 5, it will go 0 times and leave a remainder of 3. So they are congruent because they leave the same remainder. So as 12 is congruent to 0 mod 6. 12 is divisible by 6, that means it's congruent. 40 is congruent to 4 mod 9. 40 mod 9 equals to 4. Non-congruence in modular arithmetics. This means that when two numbers a and b are not congruent modulo n, if they leave different remainders when divided by n. A is not congruent to b mod n. This is simply the opposite of congruence. 7 is congruent to 2 mod 4. As I explained, 7 divided by 4, it will go once, remainder 3, and then 2, as you can see here, divided by 4 to go 0 remainder 2. So this is leaving a remainder of 3, while this is leaving a remainder of 2. So 7 mod 4 equals to 3, but 2 mod 4 equals to 2. So they are not congruent. So as 8 is not congruent to 2 mod 5, 8 mod 5 equals to 3, 2 mod 5 equals to 2. 35 is not congruent to 4 mod 6. 35 mod 6 equals to 5, 4 mod 6 equals to 4. The summary of it all. Firstly, as we said before, this is a normal clock, and then we replace the 12 on the top with a 0. Let's use mode 12 and understand congruence and non-congruence better. If the two numbers roll around the clock and stop on the same number, they are said to be congruent modulo n. Examples. 15 is congruent to 3. Now, since this is 12, we can just add o'clock. So if they say 15 o'clock, using a 24-hour clock, 15 o'clock is 3 o'clock. 18 o'clock is 6 o'clock. 22 o'clock is 10 o'clock. You can use this to understand. 15 is congruent to 3, as you can see. 18 is congruent to 6, as you can see. And 22 is congruent to 10, as you can see. So when you talk of non-congruence, if the two numbers roll around the clock, as we said before, and do not stop on the same number, they are said to be non-congruent modulo n. Examples. 16 is not congruent to 3. Since this is also mode 12, as you can see here, so 16 is not congruent to 12. 16 is congruent to 4, while 3 is congruent to 15. So they do not go together because they do not stop on the same number if you use a 24-hour clock. And then 20 is congruent to 12. It's not, because 20 is congruent to 8 while 12 is congruent to 24. If you say 24 o'clock, it's going to be a new day, so it's going to be 12 or 00. 23 is congruent to 12. It's not, because 23 o'clock is 11 o'clock while 12 o'clock is 12 o'clock. Top 10 test. So let's make this video more interactive. So you're going to answer the following 10 questions, and anyone you don't understand, please go down below in the comment section and ask. And if you don't understand, go through the video again, and I'll try my best to answer all of your questions as soon as possible. Any question or anyone you can solve in this, just tell me in the comment section below, and I will show you the solution or how to work it. So